to figure out. But in fact, it's a lot more difficult than that, and this little explanation, I think, will show you why. This is up just south of Lake McConaughey, and this is looking at the surface that geologists in Nebraska call the gangplank. And this is what the surface of the land looked like before the Ice Age. Up until about several million years ago, it was pretty much without much topography a lot of the time. And I'll show you why that is. So it looks very simple. A lot of people think this is what all of Nebraska looks like, people who've never been here. But of course, it doesn't. This is more like Kansas. Actually, I joke because Kansas isn't like that either. The only place in the US that's like this, if you could get rid of the vegetation, is Florida. But anyway, this little area called the Panhandle is a remnant of a surface that was once much more widespread in across Nebraska, and it was built up by sediment flowing out of the young and, as they aged, older Rocky Mountains and piling up east of them, making a big ramp of sediments, mostly sand in this case. So here's Scotts Bluff, and here's agate fossil beds is up here. This is the Niobrara River, and that's Harrison and so forth. So anyways, so this is in western Nebraska out in the Panhandle. And the reason I put this up is because it shows that down here we've got these diagonals are the White River sediments, and then above that we've got a Rookery, this diagonal pattern, and then we have Ogallala on top of that with these horizontal lines. So you can see all of them are represented. And if we were to make a cross section through here from Scotts Bluff on up to agate fossil beds, we'd see something like this. And this is the topography, so this is greatly exaggerated, but imagine this is Scotts Bluff, this is the North Platte Valley here, and as we go north, we go higher and higher gradually, and we find agate fossil beds up in this area, and if we continue north, we get up to the neighborhood of Toadstool Park and so forth. Anyway, you can see this, even though there's some vertical exaggeration here, there's a lot of relief, a lot of difference in elevation. And this cross section shows that we've got a lot of different kinds of rocks, and the way they fit together is very complicated. And this is because there's a history that built these layers, not all as a blanket, but a little here and a little there, as rivers first cut valleys and then filled them up, and then cut valleys and fill them up again. So what we're going to do is we're going to go back to the beginning, or at least the beginning of some of this more complicated stuff here, and take a look at that sequence. And so this is one of the ancient valleys here. It's called the PreMarslin Valley. If you look, you can see the ghost of our profile of the present landscape here. So once we had a Rookery sediment that had filled this area and was removed by a river that flowed through this area to create this valley. But a short time after that, geologically speaking, we have what's called the Upper Harrison, excuse me, or the Marslin Formation getting deposited and filling that valley up. So everything was nearly level again. But then again, a little bit later still, and we're talking just maybe a few million years, which to a geologist is just a little bit later, between these events. Another river cut through here, cut down into these soft sediments and created a valley. And then following that, more sediment came in to fill up the valley. This is, think of why this happened is something that people still argue about, but there's a good chance it has to do with long climatic cycles. That when there's a lot of water available, the rivers are powerful and they cut down into soft sediment, make valleys. But then when the climate changes, The rivers can't carry as much sediment, and so what they're carrying gets dropped and they fill up the valley. And this happens over and over again. So here's a valley fill sequence. This time the sediment that filled it is known by a particular formation name. This is actually going to be part of the Ogallala. And then, as you might imagine, a little bit after that, more downcutting and valley forming, more filling. Whoops, wrong way. There we go. More filling, and then cutting, and then filling again. So you end up getting a fairly complex. You notice the blanket isn't just a blanket. It's all these little cut and fill, dig a hole, fill it up, dig a hole, fill it up. And each time the hole's in a slightly different place, so that over time you're building this surface up into something level, the gangplank surface. So by the time you get to the end of all of this, you've got a fairly level surface. And the next thing that happens is several million years ago, the conditions change, has to do with probably regional uplift, the mountains coming up. And ever since then, the rivers have been taking material away and not leaving much behind, and carved the present landscape, which you see here. So again, this is the North Platte Valley over here. Here's the Niobrara, and you get all of this complicated stuff. Let me just kind of quickly run back through here, and I'll go through this fast so you can get a sense of this cut and fill cycling that happened. To get to our present landscape. Now you can see that that'd be tricky to work out, especially when not all of it is exposed. There's grass growing over a lot of it. And so it was geologists out in the field who had to reconstruct that ancient world by finding the little pieces that are left up on the tops of hills and figuring out how they are related to each other. And that was done mostly over about from the early 20th century up into the, say, 1980s. This is actually from a publication that came out in the 1970s by Morris Skinner, who was one of the paleontologists who did a lot of the work out here. Even so, just looking at the rocks isn't enough. We're talking about how the rocks got here, but figuring out how they fit together, how they relate to each other in time, isn't something you can do with just the rocks. What you need is fossils. And so these three layers, the White River that we're talking about, the White River group, the Rookery group, and the Platte group, you have to have the fossils that identify those groups when you're trying to do that detailed field work. And this is one of the places where the White River is exposed. This is Toadstool Park. You may have visited out in, again, the Panhandle, way up in the northwest corner of Nebraska. And this is all White River sediment that you see here. It's divided into different formations. In the foreground, lower down, we have what's called the Shadron Formation, and it's actually late Eocene in age. And then in the distance here, we have on top of the Shadron, which is underneath this there, the Brule Formation, which is Oligocene in age. And so we're talking about this being more than, say, on the order of 36 to 38 million years, something like that. And this is more like 32 million years deposited on top of it. Well, from this, lots of fossils have been collected in the Toadstool Park area, up in the South Dakota in the Big Badlands. And some of these same age rocks are exposed also around the base of Scotts Bluff, and fossils are found there. And what do the fossils tell us? Well, this is a reconstruction of the fauna, mostly the mammals that lived during the White River. Now, they've actually, this is an art, a mural by an artist named Jay Maternus that was done for the Smithsonian National Museum. And it actually throws in all the things that are found in the whole White River, even though some of these didn't live together. for example, this is, in a sense, it's really only the lower part of the White River that can have titanotheres, these guys, because they go away before the Brule. And not only that, but there are some other things that aren't quite true. They show volcanoes in the background because there's a lot of volcanic ash in these sediments, but the volcanoes that produced it were actually too distant to be visible in a picture like this. If we were in western Nebraska or South Dakota or something. Nevertheless, it gives you the idea. Also, there are climate changes going on during the time that the White River was laid down, so that if we really were to look at the Chadron setting itself, that lost world, this is what it would look like. If we were judicious in looking at our observation point, we might be able to see the titanotheres. This is down by the river, and one of the things that we see, for instance, is an alligator. And there were alligators in Nebraska in the late Eocene, and we find them in the Chadron Formation. But that's the last time. We don't see alligators after that. It got too dry for them, apparently. Maybe too cold in the winters. But anyway, so it's field parties that go out and collect these fossils that allows us to reconstruct these ancient worlds. Here's the next level, the Rookery, and here's what it looks like at the present time. This is at agate fossil beds out in the Panhandle there. And these are Rookery sediments that are under the grass. These two hills, the one is called Carnegie Hill and the other one's called University Hill. The Carnegie Museum in Pittsburgh had field parties out here excavating in the Rookery and collecting a lot of fossils around one of these hills. I think this is the Carnegie Hill. And then the teams, field parties from the University of Nebraska came out to collect in the same place. And so they set up their quarry on the next hill over. And so it was quite competitive at that time, museums trying to get specimens. But anyway, what did they find? Well, this is what they found. This is, again, our lost world reconstructed from the fossils and what we can tell about the environment from the rocks. And the Rookery was drier time than the White River. There's water there, but there are also dunes in places, and generally not a lot of trees probably, but more grassland type vegetation, which was kind of a new thing. The grasses were really just becoming more widespread, which is one of the reasons that we're seeing horses, and there's a couple different kinds of horses here. Not only that, but a couple of different kinds of camels. This is one over here. This is another one, and this is actually yet another camel type over here. So if you want to have a modern analog for what things were like in the Rookery or the Rookery fauna is, think about the African veldt or something like that. A lot of wildlife of all sorts. If we have all of these herbivores, we've got carnivores. These are what are sometimes called, well, they're amphicyonids. They're sometimes called bear dogs, but they're not really related to bears or dogs particularly closely. Here we have a giant pig. Actually, here, let's look at some closer images. These are our horses. If you look at their feet, you'll see that they got 3 toes here instead of just one. These are on the way to reducing their toes. They've got fewer than their ancestors did, but they still have more to lose to be like modern horses. Here's